Good morning, students. I'm happy to be with you this time. The last time we discussed reflection of light. And we said that reflection of light is the bouncing off of light when it hits or falls on a smooth surface. This smooth surface can be a plain mirror, glass, water, or polished metal. And we looked at the two types of reflection, regular and irregular reflection of light, the diagram and so on. So this morning, I want us to discuss refraction of light. Refraction of light. This is not new to you, as we have already discussed refraction of light, but we still have some updates added to what we have already discussed. So I will want you to copy the note and study it and listen to this video lesson. So refraction is a bending of light rays as it travels from one medium to another medium, or it is a change in the direction of light when it travels from one medium to another. When it travels from one medium to another medium. Example, air, glass, water. Everyday examples of refraction. A pencil in a bottle of water. If you look at a pencil inside a bottle of water, it appears as if the pencil bent inside the water. That is refraction. Then swimming pool appears shallower than its actual depth. If you go close to a swimming pool, you will see that the swimming pool is shallower, it appears shallower, but when you enter inside, you discover that it's deeper than you are seeing it. Then, below is an example, a diagram showing refraction of light. Refraction of light from air to glass. Air is lighter than glass. Glass is thicker than air. That means it's denser than air. If you look at the diagram, you see that we have an incident ray. Incident ray, we have a normal angle of refraction, angle of incidence, point of refraction. You see. Now, refraction changes the speed of light. A change in the speed of light causes bending. When light travels from air to glass or from glass to air, the speed of the light changes. If light travels from air to glass, for example, the refraction will bend towards the normal as it is in the diagram above. If you look at this diagram I just showed you, the refraction, this is the refracted ray, the refracted ray. Now the incident ray, when incident ray enters the glass, from the point of incidence to the glass, you see that the refracted ray bends towards the normal. This is the normal. This line, vertical line, imaginary line drawn here. So the refracted ray bends towards the normal as it enters the glass. As it enters the glass, it bends towards the normal. So, if light travels from air to glass, the refraction will bend towards the normal as it is in the diagram above that I just saw now. This is because air is lighter than glass. If the light travels from glass, which is denser medium, to air, which is a lighter medium, it bends away from the normal. it bends away from the normal, as you can see in this diagram. When light travels from the glass to the air, when light travels from glass to air, it bends away from the normal. Look at the incident ray that comes from the glass. As the light emerges from the glass, it bends away from the normal. Instead of bending towards the normal as in the first case, it bends away from the normal. So that is the second case of a refraction that you can see. Then when the light is incidented normally on the medium, okay, it's incidented normally on the medium, the incident ray is along the normal to the second medium. That means when it travels from air to glass, the incident ray is along the normal to the second medium. In this case, there is no refraction here, even though the speed of the light changes from air to glass. The angle of incidence in this case is 0. The angle of refraction is also 0. So look at the diagram below. When the incident ray is along the normal, vertically to the second medium, which is the glass. So in this case, the incident ray is 0. The refracted angle is 0, and there's no bending of light. There's no bending of the light, but the speed of the light still changes. Then the next thing we'll look at is the laws of refraction. The incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. So like the first diagram I showed you, the first law of refraction states that the incident ray, the refracted ray, and the normal at the point of incidence, look at this point, it's a point of incidence, all lie on the same plane. They must all begin from the same point. They all lie on the same plane. That is the first law of refraction. Then the second law of refraction says that the ratio of the sine of the angle of incidence to the sine of angle of refraction is a constant for a given pair of media. This law is known as Snell's law. That is, sine I over sine r is equal to n. The n is the constant known as the refractive index. It's a constant known as the refractive index. So, in summary, say that refraction is the bending of light rays as it travels from one medium to another medium, or it is the change in the direction of light when it travels from one medium to another medium. The medium we are talking about here is the material. The material can be air, glass, or water. It can be air, glass, or water. And I told you that the cause of refraction is the change in the speed of light. The change in the speed of light when it travels from one medium to another. When light travels from air to glass, the speed of the light will change. When it travels from glass to air or from water to air, the speed of the light will also change, and that is the cause of refraction. That is the cause of refraction. So the assignment you are going to do is as follows. The first assignment is this. You have to give straight answers to these questions. When light travels from water to air, in which direction does light bend? 2. What is the cause of refraction of light? 3. Does a pole appear to be shallow when viewed normally? That is your question. Please, you are expected to respond to this question and submit on our Google Classroom. The questions also will be sent there to Google Classroom. That is where I will mark and record, mark and grade you accordingly. So don't send the question to WhatsApp page. Send it to Google Classroom. Thank you very much, and God bless you.